Welcome back to the video lecture series for Introduction to the Art of Programming using Scala. In this video we're going to continue writing our file-based linked list, and in the last video we finished up our plus equals. Well, almost finished it up. I realized just after closing out the video that we did not increment the number of elements here. So with the helper methods that we wrote in the last video, it should be fairly easy for us to write the PrePin. And so that we don't forget it, we'll go ahead and increment num elements down there. So PrePin, it turns out, looks a lot like append. We create a new node. We don't want the sentinels previous for this. We want the sentinels next. So we call read next on the sentinel. Then we're going to write out the new node that we just got the index for. Its previous should be the sentinel. Its next should be the sentinel's next, and we write out that element. Now we want to take and write the previous of sentinel's next and point it to the new node. That should be a V. And then we write the next on the sentinel and have it go to the new node. And there we go. That's our PrePin. So that was fairly easy. Let's see, what's another good one for us to work with? Well, we can write apply. So remember, apply is supposed to walk through the list and find the element at index in. It would be good to require that in is less than num elements. Assert. It's not letting me do the imports. We'll hopefully fix enough errors at some point that it will allow me to do that. We can go ahead and make it so that all of the methods will compile. This one is a little bit harder here. Well, we'll come back to that. Okay, so with our previous linked list, the way that this would work is we would have, for example, a for loop. I also want in to be greater than or equal to 0. We would have a for loop for I in 0 until n. So this for loop just happens the appropriate number of times. How about location equals read next of, we can call it Rover. We'll follow the naming scheme that I typically use for my linked lists. And Rover equals read next of 0. So normally we'd say that we start off at the head of the list, which is sentinels next. We can represent that here with the read next on 0, and then we iterate through the appropriate number of times of reading off the next value, and at the end what I want to return is, do we have a, yep, we have a read data. Good. That's what we need. Read data on Rover. And there we go. There's our apply method. Clear. How is clear going to work? Now clear is an interesting method here in that we kind of have two options for doing this. Things that should happen in clear. Num elements should be set to 0. The sentinel should be set to point to itself. Okay. That's the obvious part. Now, what's less obvious is the fact that we have a whole bunch of nodes here that are now no longer being used. And one way to do this is to add them all to the free list. So we could run through from the end of the file back to the beginning and add everything that we have onto the free list. However, it turns out that you can set the length of a random access file, and so instead of keeping all of those nodes that are no longer being used around and present in the file, I'm just going to shorten the file down. So now all that it has, in fact, let's also okay. So the header that we're writing out, if you will recall, is 2 ints, and then our sentinel is going to be another 2 ints plus the A value there. Well, I'm just going to set the length to 4 times the size of int, which is 4. That is big enough to hold the header information as well as those 2 zeros that I just wrote out, and we're done. Now you might argue it's not big enough to hold the A, but it turns out that because we're using these methods, they always seek to a location that's after that. And if you want, we can put a plus record length in here. It doesn't hurt anything either way, but maybe it will make it nicer if you go look at the file after we've done it clear. Okay, how about update? So update should look a whole lot like apply. So I'm going to copy the code for apply. But this doesn't read the data at the end after it figures out the index of the appropriate node. It is supposed to write data at Rover, the new element goes there, and that's an update. What about remove? So the remove method is supposed to go find this value, look up the data, and then link around it. So once again, it turns out this starts off very much like an insert in that it has to have this loop that goes through and finds the rover. Actually, I am going to read the data, but I need to store it in a variable here. Now, after we figured that out, we need to link around this node. And we also need to have it so that this node is added onto our first free list. So first we can link around it. So I want to write the next on the previous of Rover to be the read next of Rover. Now, just typing this in, I can see that I'm going to basically duplicate this read prev and read next on the following line. Normally that wouldn't bother me so much, except for the fact that these are file operations. So because those are going to go very slow, I'm going to create variables in rprev, which is read prev on Rover, and an rnext, which is read next on Rover, so I write the previous one to point to the next one, and I write the prev on our next to point to our prev. Okay. I just want to see if I can. It looks like my assert is now happy in there. This was not the end of our remove though. So this takes out this node. In a regular linked list would be done there because the garbage collector would come and pick up the node that we had freed. That's not going to happen here. So what we need to do is we need to write prev on Rover to first free, and then set first free to be Rover. So we're basically appending Rover to the front of this singly linked list that uses the previous pointers, or uses the location where previous is stored in all of our nodes. So that then when we come back and we have to get a new one, we'll wind up pulling off this node that we just added on. Okay, so what is not done yet? The iterator is not done, and the insert all is not done, and we'll come back in the next video and we'll write those last two methods.